Hello, can you hear me? Hello, is anybody out there?
Clear. Loud and
Perfect.
clear.
Nice. Very good. This is our
Sorry,
first.
for some reason it started me off as muted. That was weird.
Well, I don't know.
Uh, can anyone hear me?
Can you hear me? Good.
Okay.
Ooh, 10 people. Half the class is here. They're all excited to do some Java. Nice. You're bored. You got nothing to do, so you might as well listen to me for an hour.
Well, that and also we have an assignment that looks to be rather hefty, so hopefully you can help us with that.
Who is this? Is Thomas? Is
Of
that who?
course it is.
Okay. Rather hefty. Okay, now let's talk about that assignment. Well, let's wait. 9 o'clock officially. That's when we start.
Sylvester, real quick. I mean, Professor Sylvester, real quick. I have a question.
Yeah, go ahead.
I can't seem to add in the CSS.
Okay, we'll talk about that.
Gotcha.
All right. Talk about that. Oh, 12 people. Boy, this is exciting. We might have to have another Zoom session after this because I don't think I can do everything I want to talk about in one day. Besides, you'll probably go to sleep after an hour or so. So we'll probably do another Zoom session. But okay, here's what we're going to do. I think I have my program over here someplace. Let me see. I got so many things here. I don't have it. Oh, no, that's it. Geez, I don't have the program. Grid. I don't have the program. Of course I don't. Oh, I do have the program. It's lottery. Okay, it is there. All right. Lottery GUI.
That's a lot of classes.
Nah, that's just the way this is right there. That's all. Lottery GUI.
Oh, yeah. Gotcha.
GUI, and then where's the CSS? Okay. Now let me run this. This is what I expect your program to do. Come on, baby. All right, that's what I want your program to sort of look like. And I wanted to also show you how you could style your application really very simply by adding, I provide you with the CSS file and you just have to apply those rules to your components. And so for now, this is not really networking. This is really a nothing program based on all the stuff that you've done so far. Okay, I just wanted to buy myself some time to talk about networking, and the actual networking assignment will be next week. And basically, I wanted to show you the different components that are in Chapter 16. Not all of them, but so right now, the only components that we know how to use are buttons and text fields. That's about it, really. Labels. But you're the generation of having radio boxes and drop-down boxes, and you should really be able to deal with those. So I wanted to show you those. And so let's just pick 5. So we have 5 quick picks, and then we'll do Mega Millions, and then we generate those things. And this is the information that gets sent to the server. It's not really doing anything. All I'm doing with this button is just reading the values of these components. And also, I also give you the code on in a previous video on how to do this. What do you call that? The radio button stuff. So that you should be able to do that as well. And oh, this is another component that's very, very important. Very, very important. That's a text area. That's probably the most important component you'll ever see. You can write the Declaration of Independence inside this text area, and you don't have to write a lick of code. It's just, basically a text area is a text field with multiple rows, and that's what I've got here. So basically all I'm doing is, I think I can type into this. I probably shouldn't allow typing into it, but you got a word processor here, like basically a notepad. So after I read those values, let's try another one. We'll send another. See, what should come back from the server are the lottery numbers that you should bet on. And let's do Powerball. Powerball, that's it. That's all you're doing for this assignment. Okay, and well, let's talk about
I got a
Mr. Murphy.
quick question, Professor.
Sure.
So for that text area, the text that gets added just gets amended to it. Is that doing like a string builder, or is that just
No,
built
you just add the text.
Okay.
You just add the text to it. In fact, just take a look at my, I got so many programs here, not fan building. What was the next, components, chapter 16 components.
Okay.
Yeah, you can download that. All I'm really doing, chapter 16 components is I'm appending text.
Okay. Yeah.
And the nice thing about this is it actually looks like Word Notepad. Let's see. Let's go here. Where I come over here. Let me run it again. Let me just do a bunch of megabucks, and you even get the scroll bars added to
okay.
it automatically. It's very, very easy to use. In fact, there's really not much to this program because it's really just applying my sample program and getting you started to sending information to the server. That also, a nice thing about this component here, a combo box, is it's guaranteed that the value that you get from the combo box will be in the proper format. Like if this were a text field, what's to stop me from, I asked for the number of quick picks and I typed Tony Silvestri in there. And well, Tony Silvestri's got a number, and if I send Tony Silvestri to the server will hiccup and not like it. So there's no error checking that you need to do in this program. But I do think if I run it again, okay, the way I wrote the program, and you could probably change it if you want. Right now, none of these radio buttons are active. And why they call them radio buttons? They're radio buttons because in the old days, they had, 5 stations on your radio. You could only hear one at a time. And so you press one button, then you press another button. If you press the second button, the first button station would deactivate and the second button station would activate. It's guaranteed that only one station would play. They call that a radio button. Okay, right now, no station's being activated here. And so it's possible that you get a null out of this. Okay, or you could just say the default would be Powerball, in which case now you don't even have to do any error checking. Okay, so when you start the program out, you could set the default to be Powerball, and you decide what you want to do. I'm not going to be too concerned about that. All right, what do you think? Oh, Mr. Murphy wants to know about CSS files. Here,
Yep.
This one, Mr. Murphy, CSS files. This is the sample program. Okay, on the scene, okay, I added this line here. Okay, and that line there says you're adding style to your components. That's why they're called style sheets. And if you're familiar at all with CSS as it applies to HTML files, it's the same thing. It really is the same thing. You select the component that you would like to apply a style to. But for now, they call them style sheets, and you can add as many style sheets as you want. All I want is one. So I'm going to call this style sheet appstyle.css. Now, where do you put it? Okay, this is my project for this file, right? That's my project. All you need to do is take that appstyle.css and just drag it inside the project. A lot of people are using packages. That's all well and good. Okay, don't put it inside the package. Okay, put it on, because I don't specify a package name here. See, there's no directory here. If there's no directory, there's no package. Okay, so if you don't specify a package where this file should be located, it's expecting that file to be located right at the root over here. So just drag it over here, and you're going to notice that it's right on the root, right there.
Okay.
Okay, that's all you got to do. It's not going to be that difficult. And then all you do is, if you take a look at the style, and basically, okay, I'll get rid of that error. You can't see it. It's difficult. But all you really got to do is say, well, geez, for whatever reason, all my radio buttons should be gold color. You can do a whole lot of stuff with CSS, and really all I'm doing is setting colors, okay, and maybe setting a border line, something that
Hello?
you could see. Okay, so you've got your radio button. Anything that's a radio button will be gold. Anything with a dot is a class. And what that means is you could apply that radio button. You could set the class to radio button for 1, 2, 3, 1,000 different components. 1,000 different components can hold this class value. All right. If you have something that's got a pound in front of it, a pound is called an ID. Okay, and where an ID is different from a class, and this particular ID, RYGP, I forgot what that means. Red, yellow, red, yellow, green pane. Okay, red, yellow, green pane. These attributes can only be applied to one particular item that's got its ID set to be RYGP. You cannot do it to 2. If you try to do it to 2 or 3 or 4, it's going to be undefined as to which of those components is going to get these attributes. So don't, if you set the ID, you can only set the ID of RYGP to only one component. Don't do it to 2. And maybe it's the first component that got set, but don't rely on that. Don't rely on that. Now, when I do run this again, let me run it again. Run. You get this nice little effect over here. See this effect? This is, first off, you see this, we got a light color and we got a darker color progressing. That's called a gradient. Okay, and where you go from one color to another, it slowly progresses from one to the other. It's called a gradient. I use the same gradient down here. I just went to a website to generate, and I specified, you can do anything on there's a website for everything, where you specify the starting color and the end color. And what that website told me to do was to set the background color of that particular button to go from this color to this color. And these specify red, green, blue hexadecimal values. All right, I'm not going to get into that too much. It's not that important. I've added a little bit of effect of a drop shadow so that it looks a little cooler. But you don't really have to know any of that stuff. Just apply it. Apply those attributes, and you get a nice little effect. The nice thing about CSS files is that, okay, great. This is a what do you call that? A program that you distribute. Okay. You don't have to recompile the program anymore. People have this. You can reskin your entire application. You've done skinning. Your generation of adding skins to your applications and your video games. All you got to do is redistribute a new app style CSS with different gradients, different colors, and you've reskinned the application with no change in no compiling necessary. That's the whole idea behind separating the functionality from the looks. It's something that I wanted to show you in this program, and I think I got a couple of submissions already that look pretty good. So give that a whirl. All right. Any problems? Any questions?
Yeah. So if we want to edit the colors, can we just edit it inside this file?
You do. You can either specify the colors. I gave you some PDF, not a PDF, a link to a PowerPoint from another book. Okay, that PowerPoint does a good job in describing all the colors. These are called named colors, where pink is pink. But if you want your own unique colors, you have to go out to a website and specify. Well, I forgot what this color is, but this particular color has the red component to be 61, green component to be A2, and the blue component to be B1. It's a mixture of those colors. You get a nice effect. Perhaps this color didn't match any of the ones that were standard colors.
Sylvester?
Yeah, go ahead.
Do you mind allowing record? Just so I can look back on this.
I have recorded. It's going to be recorded.
Oh, okay,
It
good.
says it in the
Enabled
top
it,
left.
I'll post it after we're done.
Okay, good. All right,
It's being
thank you.
recorded. Yeah. Yeah. So what do you think? All right. That's okay. That's good. Now, what ultimately what we're trying to do here is do some networking. I think networking is real cool. Networking has been part of Java since day one. And so the book has a chapter in networking. I get into it in a lot more detail than I think you really need right now. I think what I'm going to do is show you the basics of networking. But before you can do networking, what you need to do is know how to do files. Okay. You need to know how to process files before you can do networks. So you need to know the stuff in chapter 12. There's some stuff in chapter 12 that deals with the exceptions. There's some stuff in chapter 12 that deals with text files. Okay, I gave you a little homework assignment in the Revel program, and you could try those out, those assignments. But I'm going to show you exactly what you need to know about exceptions. My data structures people are going to find it kind of boring. Bear with me. We're going to do some new stuff later. Give me 10 minutes and we'll do some new stuff. But the people that just had me for Java 1, this is new stuff to you. Okay, so the first thing I'm going to do is talk about how to write data to a file. Okay, let's take a look at this program. Okay, let's see. First off, this guy, I don't know why he does this, but in his code, these particular classes, he's specifying the package that they're in, which is perfectly okay, but I don't know why he wants to type in java.io 4 different times. So what I'm going to do is do it the right way. Import java.io. Just give me every class that's in there. It doesn't matter to me. And that way there, we don't need to do this. It just looks cleaner. Let's get rid of this, get rid of this, get rid of all those java.ios. And it starts to look nicer. Okay? Now, what are we trying to do? You actually know how to do file I/O, okay? We're doing text files. A text file this is a text file right here. Anything that has standard characters with new lines, those are text files. An image is not a text file. If I try to bring up an image, it's going to look like Chinese. It's got weird characters in it. It's totally binary. There's no rhyme or reason other than a program has to know how to read that text file, that JPEG, in order to display it. That's not a text file. We're doing strictly text files in our networking. And so what I want to do is say, well, I would like to create a file called scores.txt. Okay, to create a file, you got to create a file object right off the bat. File object connects that string to your operating system. Okay, if you don't specify a directory, okay, it's going to be your project. Everything is project-based in Java. This is your home directory right there. Even though I have chapter 12 as my package. Okay, when I go to run this, you're not going to see scores.txt inside the package. You're going to see it in the project. That's important to understand. And this file object has a whole bunch of methods that you can deal with. One method is, does the file exist? Is there already a scores.txt that already exists? If it does, you don't want to overwrite the file because you can conceivably have all the scores for every of the MCAS. Okay, say this is a program that deals with storing MCAS data. There's got to be megabytes of text associated with that, with all the kids taking with their names, their IDs, and the score that they got. It would be a real shame to run this program and have it get it wiped out. Okay, so if the file exists, don't continue. I'll put a little message to say, hey, the file already exists, and just quit the program at this point. Quit the program. Now, just for my, I'm a little, I don't like what he does. I don't like a lot of things that he does, but he's exiting. The system.exit returns a value to the operating system. It's up to the operating system to determine what to do, okay? 0 is a number that says no error has occurred, okay? I think what he wants to do is return a non-zero value. That's better because an error, so what the system does is if you system.exit and you pass it 1, that 1 gets sent to Linux, gets sent to Windows, and it's up to Windows to determine what to do. A lot of times Windows doesn't care. Okay, Windows really doesn't care about a lot of these return values, but Linux does. Okay, so Linux will actually, you know, you could have a bash program, a bash script that says, oh, you know, this thing returned an error. Then maybe you can do something like send a message to, you know, send an email to somebody to say that there was a problem with this program. But it really should have been 1 or some non-zero value. At any rate, that's okay. If you get to line 13, what does that say? That says the file does not exist. So what you want to do is create a connection to this file object that you want to output to. New print writer. And believe it or not, you know how to deal with a print writer. We just never talked about it before. System.out is a print writer. A print stream, print writer, the same thing. Okay? System.out.print. Okay? So print writers, you know how to deal with. Look, you can do print and print line, print and print line. I don't know why he wants to do all these things in separate spaces, but separate methods. But here he prints no new line, print line 90. So John T. Smith in this line, you know, he created a line with John T. Smith with 90 at the end, Eric K. Jones with 85 at the end, and that was it. That's the only person. Now, very important, you need to close your file. Very, very important. You can't assume, see, and especially with this, you may have written John T. Smith to what you think is the output file, but what the system really does is it takes those prints and stores them in an array, in a buffer, some space. And it's only when that buffer gets filled up does it go to kick in the hard drive, and you write that information to the hard drive. So that's very, very important. If you close the output, it's guaranteed that that data that you outputted to the buffer goes to the hard drive. Okay? Get the idea? So you actually know how to do this. You just never created a file before. Let's run it. Let's see, there should be a scores.txt in there. So scores.txt, it's running. You're not going to see any output. Okay. Let's do a control refresh. There it is, scores.txt. And where is it located? It's inside the project. It's not inside the chapter 12, scores.txt. There it is. There's the file. Okay. What do you think? You know how to do this? Now, just interrupt me. It's okay. I can't see your hands here. Here. What could happen? This is something relatively new. Now we're going to talk about exceptions. That's your main method. That's the main method you usually create, right? That's nothing new. Let me do a source format too. Source format. Okay. I'm getting an error here. Unhandled exception, and this is what this chapter 12 talks about. It's possible. See, there's two types of exceptions. There's unchecked and checked. The unchecked ones isn't forcing the programmer to deal with them at all. Like divide by 0. How many times do you do a division? And it's possible that you could have a division where you try to divide by 0, but that will throw an error. That will throw an exception if you try to do that. But you don't have to do anything fancy. You just accept it. That's called an unchecked exception. And an unchecked exception requires nothing on the part of the programmer. What happens is if you try to divide by 0, it throws an exception and the system it's up to you to handle it in some way. Generally speaking, what it does is that exception stops execution of the current program. An exception gets thrown, and it's going to go to the operating system to print out the red gibberish that you see in the output to determine that something bad happened. Okay, so and you want that ability. It's hard to teach programming to begin with. If you had to force a normal, a guy off the street, and you wanted to force him to do programming, the guy's gonna be discouraged right off the bat, because just to do a division, if you had to force him to check, and I'm going to show you what I mean by that, he's going to quit. Now, this particular error that he's talking about here is a checked exception, and there's two ways to check for exceptions. Okay, the first way is to say, let's try to surround the code with a try block. Surround the code with a try block. So let's surround all this code with a try block. Okay, and if there's ever a problem, I'm going to take that exception that can possibly get thrown, and I'm going to figure out what to do there later, but let's do a source format of this code format. And so, okay, let's try this out. Let's try this code out. Print writer. No, I don't see any errors, right? It went away, because what I'm doing is I'm handling the exception. They call this handling. If there's a problem, like for instance, what could go wrong with the print writer? It's file. Well, let's see, what can go wrong? Okay, you specify a file, and you don't really have access, unless you're the administrator of your laptop, which you probably are. You're not going to have this problem. But if you're on a machine that many people are using at the same time, you don't have access to another guy's directory. So if you try to run this program on another guy's directory, you're going to fail right here. Okay, because you don't have access to his directory, so you can't add any files to that guy's directory. So what happens here is an exception gets thrown. All this code gets abandoned. Forget about it. All this code gets abandoned. It's not gonna run this code. Okay, it's gonna go and find a catch block that can handle that exception. And the granddaddy of all exceptions is the exception that handles everything, close to everything. And what I'm gonna do here is I'm just gonna say sys out, print out the message. Come on, what happened here? Print out. Come on. Sys out, shift. It doesn't want to do it. Okay, there it is. Error. Print out some error and just print out EX. Print out that thing in there, then it'll print out some message that you can try to handle. See, this is now called handling the exception. If you don't want to handle the exception, that means you don't want to put a try catch, then what you need to do is up here, declare the exception. You're telling Java that, yeah, it's possible for me to get an error. I understand it could happen. So just go ahead and compile the program, and throws clause. Just go ahead and try to compile the program so that it'll function. And so that way there you don't need to do the tries. Okay, that's pretty much it in a nutshell with exception handling. You can get in much more detail, but that's it. Let me see. Let's see. Okay, that's it.
Can I ask a quick question?
Sure.
So if we put in throws exception, what does that do compared to the try?
What it does is, the problem is this exception that gets thrown, in particular, it's called a file not found exception. That's called a checked exception. That means it's telling the compiler that I need to deal with that exception explicitly by either putting a try catch, or I'm telling the compiler, I know that this is it could throw an exception, so I'm just to declare that it could throw an exception. It's okay. Live with it. That's all it does. Okay, that's you either declare the exception or you handle the exception, one or the other.
Gotcha.
Okay, that's all it is. That's all it's doing. Now, there's another big problem with this program, and that is, okay, say you do have access to the file, to the guy's directory, but for whatever reason, his allocation of space is full. It's hard to believe that nowadays that can even happen. Everybody's got gigabytes of storage, but let's pretend the guy, this was back in 1980 or something, where the guy can only have like 2 megabytes of space. He's filled up all this space. You try to print out John T. Smith, and it just won't let you do it. No more space. It's present. Okay. What happens there is an exception gets thrown. Forget about the 90. Forget about Eric K. Jones, and even forget about closing the file. You're not closing the file. It's important that, you know, resources are being used up in this print writer, but they're not being reclaimed with the close. So if an exception occurs, you're not reclaiming your space, and you have a program that is not a good citizen on your operating system, and it causes garbage to be produced. You don't want that to happen, obviously. Okay. So how do you handle that? Well, that's this guy right over here, auto close. Not read data, write data with auto close. Write data with auto close. Okay. And let's see, what does that look like? It looks a little bit. Let's create the file. Okay, we'll create the file. Let's get rid of this. First off, this try block has a little slightly different syntax. Has a little different syntax. Again, with this Java IO. Damn it, I hate that. Makes the program bigger for no reason. Let's put that out there. Let's get rid of this. Get rid of that. Let's import java.io, not semicolon, dot star, semicolon. Okay, same deal here. Does the file exist? Don't overwrite the file. Basically, I'm preventing the file to be overwritten. So I'll make that one. I'm going to do a source format. Okay. But this is different. This try block, this is a new feature, relatively new feature. It started with Java 7. And that says allocate the files or the objects that you need. Okay, allocate the objects that you need. So in this particular case, in order to do these prints, I know we're writing, so I don't need that. In order to do these prints, I need to allocate a print writer. Okay, so try allocate these resources. If execution goes inside the block, they've been allocated. Okay, and guess what happens when you go out, when you get out? Okay, when you get out of it, this statement this is not a while loop or anything. This is just try, allocate the resource, do what you have to do with the resource output. When you get to the last statement, it's auto close. You don't need a close statement. It automatically closes the file. It's beautiful. Okay. In fact, I still need that throws clause. Never mind. I still need that throws clause. Okay.
Where's the catch?
There is no catch. You don't need a catch. It automatically closes your allocated space. Okay, your allocated objects. You've allocated an output object. Okay, if execution comes here, you can use it, but when you get to the end, it automatically reclaims it by automatically putting a close statement at the end. Now, if you're worried about catching, you could add a catch. Let me show you this. Get rid of this throws clause. You see, you still get this error here, but you can throw a catch in there if you want. See, it's still basically a try, and a try can have one or more catch statements, catch clauses. Exception, EX, I'm going to try, and there's not much I can do right now other than I'm going to output a system.out.control error. And let me just print out the error for you to deal with in some way. You can still do that. But the closing of the file has nothing to do with this catch at all. Okay. What do you think? That's a neat little feature. You don't, in fact, you know, you could, when I go to scanners, I actually, you know, do you remember, here, let me create a new file. New.
Inside the catch, couldn't you have it close the file or no?
Well, let's see. Okay, oh, by the way, this automatically closes the file. Even, okay, say something bad happened here.
Oh, okay.
By virtue of you leaving that block, will automatically, one way or the other, either if things went well, you're going to leave the block, you close the file. If something bad happened with John T. Smith, an exception gets thrown, it'll close the file. It'll automatically close the file. One way or another, the file gets closed. That's the nice thing about this auto close. All right. In the old days, let me show you the old days. The old days, not that old, Java 6. What they would do, first off, this didn't exist. So let me come over here. This didn't exist. This try allocator. So let's come over here, put that over there. They did this. This didn't exist. Okay. Let's try this one. Finally, I found, okay. Oh, wait a second. Move this over here. Try that, okay. Geez. See, I'm trying to mimic what that auto close is trying to do. Let me move this up here. Output, print, okay, equals null. And then I have an output. I'll put that. Okay, so here's the deal. Here's what we had to do in the old days. In the old days, I had to define a variable outside the try. Okay, because if it was inside the try, if I defined it inside, then that variable is only useful here. If I want to close the file externally, I don't have access to the variable. That's why I need to have this variable defined here. You can either do this, which doesn't make any sense, right? Close. I would see that would only close it if everything went well. Okay. And what someone told me, I don't know who told me that. He said, well, if there's an error, we can close it there too. All right. You can do it twice, but of course, this violates the whole concept of, you know, writing code once. If something went well, you closed it. If something bad happened, you closed it. All right. It'd be nice to close the file regardless of what happens. So you might say, well, here's the cool way of doing it. Finally.
Finally?
Finally. There's only one finally clause. I can put that finally in there, that close in there, and I don't need it to do here. Okay?
Oh, so it comes after the try and after the catch, always.
Yeah. So yeah, that's exactly it. Try that code. If everything went well, and there's a finally, we can close the file out. Okay? There's there's also, do you see a problem? There's a problem here. Say there's a problem with the print writer. What's to stop it from being from output? What's to stop it? If finally always executes output, it's conceivable that output could have the value null. If output has the value of null, you can't close a null. You can only close a real object. So even inside the finally, what you might need to do is say, try this code, and then catch exception, and don't do anything. I see that a lot.
Huh.
Okay, so if you try, so this definitely will catch the idea that if output was null, okay, an exception will get thrown here, and I don't do anything. I don't report it. All this code I showed you is done automatically with that allocator, with that allocators function. just defining it, defining the object that you need there. So that was a nice little addition to the language. All right, so that's going to be there's homework that you're going to run that'll make this understandable. Just do the Revel homework, and actually there's some quizzes in there that you can actually try out as well.
I wanted to ask you a question about those quizzes.
Yeah.
So after I went through the reading and I did like the questions at the bottom, it showed that the quiz wasn't done, but it didn't show me how to do the quiz.
For what chapter? Chapter 12?
Chapter 12.
There was some issue. Somebody told me that there was a problem. I tried the quiz this morning, and I didn't experience a problem. So maybe there was a glitch on the system. Try it again.
All right.
Try it again. All right. So any issues with this? Let's see. Control. I still got to get used to the Macintosh keystrokes. Okay. Okay. Now that we got a file that we could read data. Well, how do you read something? The only way we know how to read is with a scanner. Okay. That's what you do. You know how to do scanners. You did it all your lives. Scanners, your programming life. The only difference now is that instead of saying system.in, okay, that's
using the file.
You need to get the file that you created up top here. Okay, and there's a little bit. Okay, of course you could get rid of that Java IO business. Let's see. Let's see. That file better exist. Really, there's no if statement there. So what I would say is if file dot exists. If it doesn't exist, if it does not exist, then there's no sense trying to create a scanner to a file that doesn't exist. So I don't know why he didn't do this, but file does not exist. And just put the program. Return. That'll return as well. So it's guaranteed that the file does exist. We can open it up, and now it's going to get all its characters from that file. Okay. And what I would probably do is we have to understand what's going on here. We have to the file that you created is over here. Okay, it's a line. Okay, so here's what we need to do. We need to write our program to match what's inside the file. So remember, we got 3 strings and a number. So let's see how we can do this. I'm going to change this up a little bit. I would probably write it like this first. I don't like the way you did it. I'm going to say has next line. While input.has next line, true or false, is there a line? Well, yeah, there's a line right there. There's a line, the whole line. If there's a line, then we should be able to read the first name with just a regular next. That just reads a word separated by white space. Read the middle initial, white space. Read the last name, okay? Read the score as an integer. And then when you're done, make sure you clear out the line. Not has next. It wants to change it to has next line all the time. Next, okay. That's the way I would have done it. Okay, if you have a line to read, if I just did something like string line equals that, pretend you don't see this. Okay, so edit source toggle comment. If I just did this, you read the entire line as one big line. You didn't separate the number from the names. So I don't want that. So I want to go back to what we had before, separate it. Source toggle comment. All I want to do is move that file pointer to the beginning of the next line, if there is one. All right, so I got my 4 parts. I go ahead and I start printing out those parts. And it should just function. It should just function right. Come on, let's just move it over here. Okay, let's see if that basically works. Oh, and close your file. So again, a lot of stuff can go wrong here. A lot of stuff can go wrong, especially when you're reading a file. So source, boom, boom, boom. No, it read good, it read well. Now let me go into text. Change that 90 to gibberish. Okay, save it. File save, file save, file save, save. Okay, read that data. You're going to die right off the, well, you're going to read the first name, middle initial, last name, but you're going to try to read gibberish out of you'll try to read a number out of gibberish. So let's see if what happens there. Run. Where's my run? Okay, right there. Ah, geez.
Not going to be good.
Not good. There it is. See, this is the stuff that you're used to. Well, they said input mismatch. It tells you the line number. See, what happens is an exception got thrown, and I'm not. It's not a checked exception. So what happens is that exception gets thrown. You're not going to do the next line. You're not going to do the print. You don't see any prints in here, and you're not even going to do the all-important close. Okay. What you're going to do is you're going to go to whoever called you. This method is the main method. Whoever called you was the JDK. Okay, it goes up to the JDK. Now, if the JDK sees an exception thrown, its job is to print out all those line numbers and whatever that you see in the console. We need to do this better. We need to write this better, more bulletproof. So let me just copy this for now. Copy this because I did some major butchering. Copy, copy. Edit, copy this, and so you know you're going to use auto close. Okay, you're going to use auto close. Okay, let's get rid of all this stuff down here. Get rid of this. Put this on one. It reads nicer when you got this. Okay. And then what I'm going to do is just replace it with what I copied. Okay. Read data. Of course, we're reading data. See, I don't even need, the nice thing about this is I don't even need a close. Okay. I allocate the scanner. That scanner is being tied to the file. I'm going to read my characters from the file. If there's the same logic, exactly the same logic, if everything goes well, okay, I read all those lines, and if execution comes here, it does the close for you automatically. All these languages have this auto close feature, one way or another. They call them different things, VB.NET, C#. All these languages have that feature. They had that feature a long time ago. So Java was kind of late in the game with having that special feature. And let's see. Oh boy, we did 50 minutes here. I wanted to show you. Let's save that. Let's save it. I want to show you something else. The people in my data structures have already seen this, but I don't know if I think I showed you. No, maybe I didn't do this in this class. You can read an entire. You're doing networking with this program. This program here, it actually does some networking. Let's just do source format. It's sort of high-level networking. And what I'm going to try to do here is, this says read file from URL. So I'm going to show you something here. Run this, save it. Okay, that's fine. Enter a URL. Let's see, https://cs.stick.edu. There's a nice URL. Okay, hit enter. And it read the file. It didn't actually print it out, but apparently in the main page, there's 25,679 characters. Okay. I suppose I could print out the line. Here, I can print it out. It's this out. And just print out the line it read. And just to show you that basically networking requires the knowledge of files. That's all it really requires. First, you have to set up the connection to your resource. And then once you have that connection basically involves a bunch of reads, next lines, next ints, what have you. Go ahead and run it. See, there it is. If I go ahead and that's the page, the cs.stick.edu page right there. Okay. This is networking, but right out of the box of Java. Okay. So far, okay, he's got a bunch of problems here. Okay. First off, if you're going to do any networking, which is what you're going to do next assignment, you need to import. It's right over here someplace. Java.net. Makes sense. Just bringing everything in. Java.net. That way, there we don't need all these things here. Don't need this. Don't need that as well.
So we should always import.
Yeah, I always import. There's no sense in having to type out java.net twice or 3 times. First thing you're going to do is you're going to read the scanner for a string. So the normal scanner here. First off, I don't like when he does this. First, I'm going to have a scanner, normal scanner. Input, and that's equal to. Okay, semicolon. We got the scanner, and then what we're going to do is from your input. He likes to use next. I like to use next line in this case. The entire line I type in is going to be the URL. So that's going to be called a URL string. So that's going to be a string URL string equals. Okay. So it didn't really do too much here. Let's see. We got that. Oh, I don't know if I've ever mentioned this, but I'm going to mention it now. Better late than never. You define a variable up here. Okay. Once you define a variable up there, you cannot use that same variable name inside a nested set of brackets. That's why there's an error here. Even though by right you should be able to create another variable inside the brackets, you can't use the same name because you used it above. So that's something you need to have another name. So what do we want to call this? I'll call this network input. Net input. Okay, network input, because you're reading your characters from the network. First thing, that string has to be converted to a URL. You're going to see that in your networking. Okay, a string is just a string. A URL is an actual object that gets, that string gets parsed out, and the protocol gets read. Whether you're using HTTP or HTTPS, whether you're using FTP, that's the protocol. What port? If you specify a special port, that gets all dissected by this URL object. Okay, so that's all you got there. You just dissected the string, and if it's okay, then what we're going to do is open up a connection. You open up a connection to your remote resource. It could be a server in China. Okay, and you open up a stream. That creates, whenever you see the word stream, what you've basically created on this URL, you've got the ability to create a stream of bytes. You're getting a stream of bytes from that URL. That stream of bytes gets sucked into the scanner. Just like when you do system.in, your stream of bytes is your keyboard. Okay, if you have a file object, your stream of bytes is going to be the file. All you do is you take your URL, open up a connection, open up a stream, and what you've got now is a stream of bytes that the scanner can use to do its input. Okay, that's it. You've done your networking right there. It's so easy. It's a little bit harder than that when we do. We're not going to do networking right now, but I guess the next class. Okay. All right. Now I've got my scanner. It's got a stream of bytes ready to be input. Now, see, there's no error here because it thinks that this input is being connected to the scanner from the keyboard. So You don't want that. You want net. You want to read while net input, while you've got your input from the network, has next line. I like that better. Does it have a line? Well, if it does have a line, if there's no more lines, you're at the end of the file, you're good to go. What you're going to do here is say, I'm going to read that line. If you have a line, this doesn't actually read the line. It looks to see if there's a line present. And if it does, if there's a line that's present, you're going to read that line. And now you can do whatever you want with that line. You could print it out. It's not printed out. It's too long. It's a big file. And what I'm going to do is figure out how many characters in that line, count them up. And then after we're done, we'll report how many characters are in the line. Okay. Now I want to show you something here. And that is, you can have multiple catch blocks. Okay. And what the system will do is say, well, geez, if something goes wrong, here, I can make something go wrong really well. Here, URL. Does that look like a URL?
Not really.
Okay, so input. So right off the bat, it says invalid URL. Okay, so it died here at line 13. Line 13, it doesn't even bother continuing this. And so what the system does is it says, okay, find the first catch that could possibly that can handle that error. Well, you have to do a little bit of ferreting it out. Let's see. Oh, there it is, right there. Just to hover over it, it says it could possibly throw a malformed URL. Okay. What the system will do, so what you're going to do is you're going to say, well, malformed URL, EX, and what happens then is it's going to, this particular clause, block, is going to catch anything that gets thrown that has that's of type malformed URL exception, in which case you're going to output invalid URL. I can't really simulate IO exceptions too well, but if there was like a network error between between, you know, you're trying to read something and there's no, say China killed the connection, okay? They see that it's coming from Massachusetts, they don't trust us, and so they kill the connection. You're in the middle of reading something from their file, that's going to be an IO exception. But so you have to sort of handle that. If you don't handle it, what happens? Let's take a look at it.
We don't have to write always java.net if we import the file, right?
No, if you import the file, you don't have to. You don't have to do that. That's why I don't know why he does it. Okay. Well, let's see. What to figure out how many catches you need. You know, you could do. You know, just go ahead and write the code. Surround it with a try catch, and then if you see the compiler complaining, oh, I didn't handle IO exception, then handle it. Throw another catch block. Okay. And then at the end, if you know, it's possible that you can have a bunch of exceptions that you didn't really anticipate. The granddaddy of all exceptions is the exception. In which case I can go ahead and say generic exception, error, colon, and then I'm going to say plus EX, and you're handling the generic exception.
Can I ask a quick question?
Sure.
Does malformed URL exception only apply if the URL itself is wrong, or if it doesn't find a website with that URL?
If the string is bad. If the string
So
is,
if it can't find the website, what exception
No.
does it throw? Is that IO?
that would be an IO. Oh,
Gotcha.
let's try something. Well, maybe we can do IO errors. Hold on. That's a good question. That's a good question. Okay. HTTP : www.com. It might get upset with this semicolon here. Let's get rid of this. Okay. All right. Let's try to open up a connection to that. IO errors. Very good. Thank you, Thomas. There it is. See, I tried to open up it didn't die here. It died over here because you tried to open up a connection to a non-existing web server, and so it just died and said IO exception, IO errors, right there. And another thing I want to show you is that the order in which you do these catches are important. I can't do this.
Because then it'll catch every exception.
This will
that
catch
way.
it. Yeah, it's literally what happens is it goes, the system will first find the first, it goes in the order of the catches specified. If you specify the granddaddy of all, then everything matches an exception. So it's going to say, well, why do I got this? Why do I got this? Because basically a malformed URL exception inherits from exception. Ditto on the IO exception, they inherit. This is the parent. These are the children. Okay, so the parent is compatible with the children that get sent are compatible with the parents. Okay, and so you got to make sure that the generic one goes at the very end, right there. So what do you think? While we're here, let's do something here. I want to show you something. That's all I want to do. Now that we know about, and this will be the last thing we'll do, and then we'll do the actual networking code. How about on Friday? You want to meet on Friday? Same time? 9
Sure.
o'clock? Okay, Friday time, same time, 9 o'clock. I'll send out an invite. But I want to just, what I want to do is this. I'm going to copy this, put it here. Oh, what the hell did I just do? Move it here. Okay. Move it there. Come on, dude. Okay. I got that. I want to allocate my input. See, this is something that you can do. I'm going to allocate my keyboard input. So if everything goes well, I can go ahead and put that code in here. Let me do a source format. Okay, move that there. And then clean this up a little bit. And then what I could do here is a try, and let's allocate this guy inside here. Gotta make sure we match it up. Do a try there. Right there. See what the previous code, by the way, the previous code was bad. Okay, the previous code had a scanner that was connected to a website. Okay, scanners need to be closed, especially when they're connected to a website, because you're using a lot of resources. Did you see a close anywhere in this code? No, there's no.
No, I did not.
That's right. So that was bad code. That's a 5 out of 10. 5 out of 10 for that code. No good. Junk code. Okay, so source, let's toggle, not format that guy. Okay, that looks better. So now this is much better code. Much better code. Let me just clean it. I don't like the way it formats. I like to have my catches all aligned here. Okay. And so what happens is once we're done with this input, it gets closed. Okay, it gets closed. And then we claim those resources. And once you're done with this entire program, even the input scanner gets closed. If there's any errors anywhere, okay, you automatically get everything closed because you got out of the inner try, you got out of the outer try, and then you're just going catch. You're trying to execute catch boxes. It's guaranteed that the resources were closed with this code. I think that's much better. So what do you think? Can we do chapter 12?
I think auto close is really nice.
Yeah, it is nice. It is nice. So you got the basis for networking. Okay. Your next is, so right now you really can't do the networking part of this assignment yet until Friday. Friday, we need to show you. This is high level networking, very high level networking. Okay. The only networking that I showed you here is the URL and the open stream. We need to delve closer into the network. I want you to write a program that connects to a program that's running on the CS machine. And I need to show you the protocol necessary. I got to show you a lot of stuff. And all that stuff is inside here, the networking code that I gave you for you to download. So why don't we stop here while we still have some sense. Okay, stop right here. And we'll see you Friday. I'm going to send out an invitation. I have to send it out manually because I can't put it on a website because people what do you call it? They bomb the Zoom sessions with pornography, and we don't want that. Okay, they need to know about. Only certain people need to know about these Zoom sessions, so I need to send it in an email. All right, we'll see you Friday.
See you Friday.
All right, my friends, we'll see you then. Let's see here. Everybody's here. Pretty much everybody's here. Yeah, boy, look at this. Look at this. Very good. Thank you. Bye. Stop to share. End the meeting.